so we're going to try this one more time. I think what happened is this is that one day of the year that the entire internet decided to start doing drugs or something of that nature because there are a variety of different things happening across the interwebs that are causing grief. So I'll try and make this as quick and as short and sweet as I can. This is kind of introduction to going from DNA to RNA and then finally into proteins. The problem is that proteins are made up of amino acids. And so it's really difficult for people to make sense of whether or not they're doing this process correctly. So rather than using amino acids, I'm going to replace those with actual words. And then when you put those words together, they should make a meaningful sentence. And hopefully you'll figure that out by the time we get through this first example. So that's the goal of this exercise I sent you. Understanding that video link is probably going to be broken. I'll post a new link on the website under the control page so you guys can access this readily. Now, if you read the directions here, there is a page on the very last portion of this document where I want you to type your answers and then you'll submit this back to me through Google Classroom. What you've got here are a list of 20 DNA fragments. There are 18 here and then 2 more on the next page. These DNA fragments are just listings that are matched up in sets of 3, as you can see. There's a purpose to that, as you'll find out. There's another thing to note here. They all begin with the same 3 letters, and they all end in the same 3 letters. That isn't an accident either. So what we're going to try to do is take this random smattering of letters here, A's, T's, G's, and C's, and we're going to try and translate that into a meaningful sentence. So it's basically code breaking. So what I'm going to ask you to do is take these DNA fragments and you copy them over to the last page. So what I've got here, I took that first DNA fragment and copied it over to the last page. What I'm going to do is I'm going to type in 3 more lines. The first line is going to be mRNA. That's the process of transcribing. You're going to make a working copy of the DNA. This is the strand that you're going to read to do that. So all you got to do is follow the base pairing rules. However, don't forget, opposite of an A is usually a T, but because it's RNA, it gets a U. So your first 3 letters are going to read U, A, C. Then you keep going. U, U, G, U, C. Now here you've got C, A, and then U. Still got A's present. Those will still bond to T's, but you can't place a T opposite of A because you don't have them. RNAs have U's. Next one's going to be G, U, G. Then ATC, we're going to have U, A, G. And then the last 3 letters here, we're going to have A, U, Z. Let me just check those over to make sure that I haven't made any errors, making sure that the base pairing rules are being followed. Now, I know these don't match up exactly. The spacing is a little off. That's not a big deal. Now, the reason I color-coded this red is so that I can keep track of it. The red is going to be important. On the next line, then, this is going to be tRNA. The tRNA isn't really going to be read for anything, but it does have to be complementary to the mRNA because linked to the tRNA is going to be a word. So in order for tRNA to read and match up with this, it's also got to be complementary. This one's going to be AUG. Now, if you note, the tRNA is going to be almost identical to the DNA, except everywhere you saw a T, it's going to be a U. So that makes this one real easy to go through. You can kind of race through. It's going to be AA, it's going to be AC, and it's going to be AAG. Now, we got GA, that's B, G, U, A, and then CAC, and then we got A, U, C, and then U, A, G. Okay, so we've got the DNA reading strand, the mRNA working strand. These are in 3 base sequences called codons. Okay? The 3 base sequence that matches up with a codon is called an anticodon. So now all we got to do is fill in the words. But you're not going to read AUG. You got to read the mRNA. And that's where you come back to this page. There's an mRNA codon. So you're going to read, you're going to read the mRNA codons. So the first code is UAC. What goes with that? Start. That's the beginning sentence. That's why all of these begin with the same 3 letters, because a sentence always starts somewhere. They're also all going to end with the same 3 letters because you always finish a sentence with a period. Okay, so we're really concerned about this start codon. So if I go here, UAC, that's start. So I'm going to start with a capital letter. So we're going to immediately go to the UUU. If I look at UUU, that's your. So I'm going to type it in. Your. I'm going to back this up just a little bit because I don't need all those spaces. So the first word is going to be your. That comes from UUU. The next one is UUG. What word is that? Mother. There it is right there. So your mother. Next one is UUC. UUC bears. So I'm going to type it. Next one, CAU. Got to look for that one. CAU. There it is. A. GUG. Rubber. Next word, UAG. Band. So I'm going to type that in. And then the last one is AUC. AUC period. That's the end of my sentence. When I read that, your mother wears a rubber band. It might be goofy, it might be silly, but it makes sense. Grammatically, I understand what the sentence is trying to tell me. If this sentence turns out to be gibberish, you could be doing something wrong. You could either be transcribing from DNA to RNA incorrectly, or you're reading the wrong line. You could be reading the tRNA line. That's not the line you want to read. So I'm going to put strike through on this. Just so I know not to read that. It's there. And I went through and I decoded it properly, but that's not the sentence I want to read. I go directly from mRNA to words. I hope that makes sense? Try a few of these. You got 19 more to do. And if you start to run into gibberish, email me and we can talk on Wednesday and figure out what you could be doing wrong. Okay, good luck. And hopefully the video works out and we will talk more.